Ladies and gentlemen, welcome to another session of the Nambani Academy. Thank you very much for all the support that you've been giving us. The numbers are definitely showing that there's growth and support from your side. So if you have not subscribed yet, kindly subscribe and like our videos. Remember, we also have a very nice website which is called now nambaniacademy.com. That is where now you'll find all necessary resources and extended material that we want to distribute and help you with your physical sciences. Fortunately enough, we've managed to create time for recording term 2 content, which will be rates of reactions, work energy and power, as well as chemical equilibrium. So be on the lookout and inform a friend about us so that we can also be now in a position of ensuring that each and every one of us now achieve. So without wasting any time, let me quickly get straight into it. And today we will be focusing now on rates of reaction. So with rates of reaction, obviously the key thing that we need to start working on is exactly what is now rate of reaction. And remember now, for the purpose of definition, it is always advisable to use now definitions as per the exam guideline, as per the CAPS document itself. So we define rate of reaction as the change in concentration of reactants per unit time. So per unit time, we say now it is the measure of how fast or slow is the reaction. So we are going to be interested in what will be the factors that influence how fast or slow is now the reaction. So this is only influenced by the measure of time. That is the reason why we define now change or rate of reaction as change in concentration of reactants or products per unit time. But furthermore, the examiners have also accepted a definition of rate as rate at which rate at which reactants are used. And they can also accept now another one, which is just rate at which products are formed. So these are two extended definitions that one can use. But now let's look into it. The word rate is already there. The word rate is already there on the second one. So what does this say to me? It says, if I am going to use definition number 1 and 2, I cannot use the wording per unit time because rate is already part of the definition itself. So if you are going to give a definition using rate at which reactants are used, then it basically says it is important for one to realize that it is important that you do not have the word rate and per unit time at the same time. So if you are going to give a definition in terms of rate, just start by saying rate at which reactants are used, rate at which now products are formed. If you are now going to use the one of change in concentration, it will become easy for you to be in a position of saying change in concentration of reactants or products per unit time. It should not be having per unit time as well as the rate. That now you will be penalized for that and you will not get the 2 marks that we intend on you getting. But obviously, because it is a measure of how fast or slow is the reaction, obviously there should be now factors that influence the rate of the reaction. Factors that influence the rate of the reaction. The first one, it says it is the nature of the reactants. The nature of reactants, I will explain further when we get into explaining each and every factor, how it influences the rate of the reaction. The other one is concentration, surface area, temperature, and a catalyst. But I want us now to look into this critical information that they say here. It says the higher the concentration, the faster the rate. So when we get into the collision theory, please be on the lookout for that. When we increase the rate, the concentration, we are basically increasing the rate of the reaction. So when we increase the surface area, we are actually increasing the rate as well. So basically everything looks like it's somehow proportional here in terms of if I increase the concentration, I'm actually increasing the rate of the reaction. If I'm increasing the surface area, I'm actually increasing the rate of the reaction. The higher the temperature, the faster the rate of reaction. And for the mere fact that we have worked with uh, catalyst in grade 11 and grade 10, and it is now known as a substance that increases the rate of the reaction without undergoing any permanent change. So we are also going to look into the mechanism of how a catalyst does now increase the rate of the reaction. Furthermore, there are calculations related to rate of reaction. Because remember, it is a measure of how fast or slow is the reaction. So the calculations thereof inform us in terms of how fast the reaction is. But there is no equation that will be given in the formula sheet about calculating the rate of the reaction. So it is very important for one to say, kindly now note this one and be able now to remember or to memorize. That is now very, very important for you to look into. Memorize these equations, know these equations, because these equations are not now in the formula sheet. But we can use a definition, like we said, change in concentration per unit time. So that basically says I am going to have my equation as rate is just equals to the change in concentration over change in time. So allow us to use a definition as a form of remembering this particular equations. Change in concentration of reactants or products per unit time. So we can use now the definition in order for us to remember this in an examination. Now, I'm going to start with determining the rate of the reactants. Now, remember, reactants now in our reaction, they always have now a decrease in mass, concentration, or even the number of moles. They always have a decrease in number of moles, in concentration, as well as in mass. It can even further be in terms of the volume that we have. So the emphasis here should be that note that for every equation that is going to be dealing with a reactant, it must have this negative sign here. It must have this negative sign. So what is the meaning of the negative sign? The negative sign just emphasizes that the reactants are decreasing, but we can never get now a negative unit for the rate of the reaction, because it is the measure of time. Remember that. So time is always positive. That is the reason why it will depend on what is it that I am giving. If I am giving now concentration, if I am giving concentration, this equation will become now constant change in concentration over changing T. And this will link now to the first SI unit, which will be mole per decimeter cubed per second. Furthermore, this year, if I am given the mass, will just be changing mass over T, then that will relate to the second equation, because we know the SI unit of mass is grams. The SI unit of time, it's second. So according to the definition itself, it allows us to be in a position of saying definitely the correct SI unit should be grams per second. With that being said, we can also be given in terms of change in volume. That now the SI unit for volume, it's decimeter cubed, and the SI unit for time, it's per second. We can also be given that now in terms of moles, and then we'll have your mole per second. So it basically says we do not have a standard SI unit for the rate of reaction, but the rate of reaction is influenced by concentration, mass, volume, or moles in terms of the calculations that we want to perform. So be on the lookout. What is it that the examiner is actually requesting you to do in terms of the calculations thereof? So this is a way of saying we know a definition, we know how each factor influences rate of reaction. We now know how to calculate also the rate of the reaction. But with that being said, it says to us, then we need to have a way of understanding and how to represent this information graphically. We said it is the change in concentration of the reactants or products per unit time. Can we draw a graph and understand now what is it that this information that is here, the gradient of the graph that we are going to draw, is it going to assist us in order to be able to understand the basic concepts of reaction rate? Let's move further on. It says now, measuring the rate of reaction. I want us to put into mind the equations that we spoke about. The equation for concentration or mass, volume, as well as the moles. So the key thing is now we want to represent the rate of reaction graphically. By so doing, the first one is we can do that by measuring the volume of a gas released per time. So we can use an experiment for us now to be able to measure the rate of the reaction. So this now basically says, okay, fine, I can be in a position of collecting the gas that is released for me to be able to measure how fast or slow the reaction is. So this will be just the apparatus that one must use. This will be your Erlenmeyer flask. This will be your Erlenmeyer flask. And then this will be just your syringe for one to be able to, this will just be our syringe in order for us, to actually measure the volume of a gas that is now released. So what does this say to us? It basically says, because I am focusing on the product that is formed, remember this will be my reactants, this side, and then definitely the gas that is produced will be now my product. So what is the meaning of this? The meaning of this is basically says my reactants are going to decrease while my products are going to increase. That is the reason why. That is the reason why you have now your products at the beginning of the reactant of the reaction to be equals to 0. Because at the beginning of the reaction, you do not have any products being formed. So the products will form while you have your reactants reacting until a certain point where now the graph becomes constant, and then it says now the gradient becomes 0, the reaction has stopped, no more gas is formed. So it basically says here now the reaction is complete. It is not at equilibrium, the reaction is complete. But it says further, the steepest gradient initially means now you are going to have the fastest rate. So if I can choose 2 points here where I have A and B, this would be a clear indication of my rate of reaction is very, very fast. So when I have the steepest gradient, then it basically says I am indeed having the fastest reaction. So the steeper the graph, the faster the reaction. Why? Because at the beginning of the reaction, I still have a lot of reactants before they can actually decrease in terms of the concentration, in terms of the number of moles, in terms of the volume of the reactants, as well as the number of moles. So this basically says it is going to decrease as now the reaction goes with time. That is the reason why eventually you will say the reaction is complete because now no more gas is formed. That is a reason why we say eventually you will have your horizontal line, and that horizontal line will represent that now the reaction is complete. So as the gradient decrease with time, the reaction rate also decreases, and this means now the rate of reaction becomes very low and the amount of the reactants decreases. So when you get a graph now, it basically says we can be able to associate the graph with the rate of the reaction. If I were to write now a formula to explain what will be represented by this gradient, it will be easy because we said rate is just equals to the change in volume over the change in time. So because of I am given my volume of a gas that is produced over time, that gradient will now represent the rate of the reaction. What will be my SI unit if I may want to emphasize? It must be centimeter cubed per second. Why? Because our volume in this instance is given as centimeter cubed. Furthermore, this is the first way of measuring rate of reaction by collecting the gas that is released. So this will be the practical section of rate of reaction, but we'll further explain the variables that are involved: your independent variable, your controlled variable, uh, independent. So that will be now the second part of this video, where we explain each and every experiment, where we explain what is it that now the examiners are actually willing and looking forward for you to actually know. So as part number 2 here, in terms of measuring the rate, you can measure rate by measuring the loss of mass of reactants per time. So remember, at the beginning of the reaction, here I have now my maximum reactants. This is now at the beginning. So what will happen as the reaction takes place? It's very easy. The reactants are going to react in such a way that there's going to be a decrease in mass of the reactants. Why? Because the reactants are actually producing the products. So it basically says the steep initial gradient indicates high rate of reaction. Gases form fast, escapes, and then the mass is lost at a higher rate. So it basically says I am going to have my steepest gradient somewhere there. Then I will have my A and B that will now represent the fastest rate of reaction. Eventually it will decrease, and then I'm going to have that horizontal line. It says the gradient becomes 0, no mass is lost, the reaction is completed. So understand the shape of the graph. If it's starting from 0, it basically says the focus here now is products. If it's starting now from a certain specific high value, definitely the focus should be on the reactants, because at the beginning of the reaction I have a very high number of moles of concentration, the mass, the volume. So depending on the quantity that the examiner is giving me, but that is what I am going to be looking for. So remember the shapes. The two shapes actually emphasizes what the experiment or the investigation is all about. How quick can you produce the products, or how quick can we lose the reactants? So be on the lookout in terms of this graph. So to further explain again, in terms of, can we now be able to associate the gradient of mass versus time with rate? Definitely we can. That is when we say rate is equals to the change in mass over the change in time. Then the SI unit will just be grams per second, depending on what is it that the examiner has given us. So we are going to stop here. The only reason for that is we are breaking it into smaller sessions so that each one of you can be able now to access the section that you feel that you are interested in, instead of making one long 2 hour video. We have decided as a team to say, let's break it into small pieces such that you can easily go into sections that you do not understand of the topic. So ladies and gentlemen, from me to you, like I did say, my name is Mr. Nambani, and thank you very much for the support once more. Kindly subscribe, tell a friend. We try to simplify the concepts of science, so follow us and kindly remember to tell a friend. With that being said, thank you very much and see you on the next one.